Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231, Further Probability and Statistics, Topic 5, Probability Generating Functions. This lesson regards 3 or more random variables. Let's consider a probability distribution for variable x with 3 outcomes. Those are 0, 1, and 2. 1 over 2, 1 over 4, and 1 over 4. The relevant probability generating function is 1 over 2 plus 1 over 4 times t plus 1 over 4 times t squared. And given this distribution, let's consider 2 scenarios. One, we want the probability generating function for multiple variables. These are independent variables, but they have the same probability distribution. And the second scenario, functions in x, y is 3x minus 2, and z is 4 plus 4x. On the left, extending the rule we've previously learned for 2 variables, we can apply multiplication to the probability generating function for the first variable times the probability generating function for the second variable times the probability generating function for the third variable times the same for the fourth variable. And as these are all the same probability distribution function, we're multiplying the same thing 4 times, and we can simplify as the probability distribution function for variable x to the power of 4. 4 here is a particular case. It could be 5 or 6 or as many times as is required. In the second example, we're looking at probability generating functions for functions. Let's identify for y, a, and b, and for z, a, and b. And here our requirement is the sum of the probability generating function for y, which is 3x minus 2, and z, which is 4 plus 4x. And applying the concept that the probability generating function for the summed variables is the product of the probability generating function of the individual variables. We have t to the power of b, first b is negative 2, times the probability generating function for x with an input of t to the power of a. In the case of y, the a is 3. And we will multiply for z, t to the power of b is t to the power of 4, times probability generating function for x with an input of t to the power of a. A is also 4. Notice that what we are keeping separate is function y, 3x minus 2, and function z, 4 plus 4x. So we are not saying this is not equal to the probability generating function of, if I look at the 3x and the 4x, combining those to 7x, and if I look at the negative 2 and the 4, combining those to plus 2. We want to keep those two functions separate. From here, I won't continue the workings, but notice that for the example on the left, we're working with the probability generating function for x, which we have up at the top. And in the example on the right, we're working with the probability generating function of x. We're replacing t with t cubed, so we have the probability generating function that we need, and the same probability generating function replacing t with t to the power of 4. So there also we have the required probability generating function to work with. A comment regarding the second example. If we were dealing with a scenario with more than two functions, y and z. If we had a third, a fourth, a fifth function in x, we could apply the same concept to find the probability generating function of those combined functions. And this completes the lesson on probability generating functions, 3 or more random variables.